It is one of the main gases that's in natural gas, which comes out of your stove. Methane is third on the list of greenhouse gases, and yet it contributes per volume 23 times more to the greenhouse effect than carbon dioxide, which is on the top of the list. The reason for this is that methane, when in the air for a while, will decompose into other gases which aren't as bad greenhouse gases. Carbon dioxide will stay as carbon dioxide for a very, very long time in the air, even though it is per volume a much less potent greenhouse gas than methane. So methane is the shortest hydrocarbon, and when you burn it, it turns into water and carbon dioxide. If you continue increasing the length of the carbon chains from 1 carbon, which is methane, to 2, which is ethane, to 3, which is propane, all the way to hexane, which is 6 carbons, then it becomes a liquid. And you can see I've got hexane in this bottle. So this is the same basic kind of molecule as methane, only it's much longer, so it's a liquid. Here I have gasoline, which is primarily a mixture of this kind of molecule, which is called an alkane. So it's primarily a mixture of alkanes of varying length, all of which have to be liquid since gasoline is liquid. So the shortest alkane you're going to find in gasoline is hexane, and it goes all the way up to duodecane, at which point it becomes a solid. Past that, it's basically tar. Of course, tar has many other things that aren't alkanes, but alkanes are a major component of tar. And so gasoline is just a mixture of these different alkanes, and that's why when you burn it, it makes primarily water and carbon dioxide. What's very interesting about these liquid alkanes, and why I've got a bottle of pure hexane, is that unlike water, which has very high surface tension because its individual molecules are very polarized, meaning there's a positive end and a negative end, these alkanes, these liquid alkanes, have almost zero polarity. So they've got almost zero surface tension. What this means is if you filled a glass with a liquid alkane, the minute it got to the rim, it would start spilling over. With water, you can get a few millimeters above the rim before it spills over. Another thing that's interesting about nonpolar liquids is that many things that won't dissolve in water will dissolve in these nonpolar solvents. In a minute, I'm going to show you styrofoam dissolving in gasoline. And I've dissolved about twice this volume already in just 50 milliliters of gasoline, and you can see that there is not very much volume. This means that this is primarily air. So let's watch this reaction happening in real time. I'm going to put in this piece, start pressing it in, and if you can see, there are bubbles coming out. That's the styrofoam dissolving in the gasoline and forming what's known as a gelled salt. So I'm going to keep dissolving this, and then I'm going to show you this burning.